1.6. We're dealing with linear pairs. A linear pair have non-common sides. Okay, the non-common sides, of the adjacent angles form a straight line. In other words, you've got an adjacent angle. Remember, adjacent means they're connected and they share a side. But the sides that are not connected, they make a straight line. So you've got the angle ABC and the angle DBC. They're adjacent. Share a common vertex, common side. However, they also, that segment AB and the segment BD make a straight line. They're collinear. All right? That means those two angles added together make 180 degrees. Linear pairs, those two angles add up to be 180 degrees. Okay? Example 1, we want to determine whether angle 1 and angle 2 are adjacent angles, and then if they are, which ones are linear pairs. First one, 1 and 2, are they adjacent? Yes. They are. They share a common vertex and a common side. Where's the vertexes?
The middle point, the middle line.
That's their common side. So you're saying this is their common side. Where's their common vertex? So is that a common vertex? And is it a vertex for both of them? No.
There is none.
So it's not an adjacent angle. Because these are not common vertexes. They don't share the same vertex. Their vertex is on the end of the line segment, but they're not common. They're not the same one. How about 1 and 2? Do they form adjacent angles? Are you sure? They have the common side, same vertex, so they are adjacent. Okay, so are they a linear pair? Linear pairs, what are linear pairs?
They add up together to make 180.
Okay, they add up together to make 180. Now 180 is a what? A straight line. Do they make a straight line? So it's not a linear pair. Good. All right, how about this one? 1 and 2, are they adjacent?
Yes.
They are adjacent. Are they a linear pair? They're not a linear pair. Okay, so are 1 and 2 adjacent?
Yes.
Are they a linear pair?
Yes.
And yes, they are a linear pair. Okay, so here we go. We're going to name the angle, so we have to name it correctly. The angle that forms a linear pair with the angle TCM. Well, the easiest thing to do is look where TCM is. TCM is right here. And we want to see the angle that is a linear pair with it. Okay, she says TCE. Anybody have a different one? Why do you think that is it?
Because TC makes a straight line.
Okay, TCE makes a straight line. What else? It has a common vertex, and it shares a side. So she's right. So angle TCE. All right, linear pairs have to have the common side, the common vertex, and make a straight line. Now here's something different, complementary. There's two words we're going to talk about, complementary and supplementary. And the way that I remember it is C comes before S, 90 comes before 180. All right, C comes before 1S, 90 comes before 180. Complementary are two angles that when you add them together, their measurements equal 90. They do not have to be side by side, but they can be. All you have to do is take two angle measurements, add them together. If they equal 90, they're called complementary. All right, the complement of ABC is angle DEF. All right. Do not have to be side by side. They don't have to have a common vertex or a common side, but they can. All right, supplementary. Remember, C comes before S, 90 comes before 180. Supplementary are two angles that add up to be 180. Now, a linear pair are supplementary angles. They're connected, but they don't have to be supplementary. All right, 45 plus 135 equals 180. Right? That means that they are supplementary angles. All right. Supplement, you may hear the word supplement. It's just talking about one of the angles. What's the supplement of measure or angle MNP? Maybe the angle RST. Yes, very good. Name two pairs of complementary angles. What's complementary mean?
They add together to make 90.
Good. They add together to make 90. Can anybody give me a set of, hold on, she raised her hand.
FGE and EGD.
FGE and what? CGD?
EGD. Yeah, that's sorry.
CGD. Good. All right, she's right. So angle GE, the vertex has to go in the center. GE and angle CGD. Okay, that's one. Can I find another one? All right.
Angle
FGA and CGB. She's right. So angle, well, I did it backwards. AGF, that's the same thing. And angle CGB. Are there any others?
Yeah.
Okay.
Angle SGB.
Angle SG. Okay, so AGE, that's 180 plus 55. Well, that's already bigger than 90, right?
Where's 80 at?
Right here.
No, which one angle is 80?
FGE.
Well,
But if you do AGE, you've got the 80 and the 55 together.
I mean,
We've done that one. Good. Any others?
You just have one pair?
Okay, can you have one pair? No, because they have to be two. Okay, so it can't be the 90-degree angles. So that's it. All right. So we've got those. And we're looking at example 4. Name a pair of non-adjacent supplementary angles. What's non-adjacent mean?
don't have the little line thing, the same size.
Good. They don't share the same side. Okay? So these are not going to share the same side, but they still make supplementary angles. Can anybody give me one? A, G, B, E, yeah? So he did the 90-degree angles. Whoops. 90 and 90. Add up to be 180. Okay, that's right. Can you come up with any others? FGA and DGC are not going to quite be 180. Okay.
Does it have to be 80?
It has to add up to be 180. It isn't.
Hold on. What's that other angle over there?
This one here? It's 10, which is 35. Yeah, same thing. In example 4, find the measure of an angle that is supplementary to the angle BGC. BGC. And I want an angle that is supplementary to it. So it has to equal to 180. You have to name them as 2.
Okay, so
AGE. Well, 80 plus 55 and 35 are not 180.
I just get
It has to be 2 angles.
It has to be named as 2 angles.
FGA and AGB.
Okay. You can't name it that way because we've already got 1 angle and it's named for it.
FGB.
Thank you. So she's saying angle FGB. So 90 plus 55 is 145 plus the 35. And they are adjacent. And they're a linear pair. Very good. All right, you ready for a hard one?
Yeah.
There's no pictures. Okay, here's your deal. Angles C and D are supplementary. What's supplementary mean? They add together to equal 180. If the measure of angle C is 12x and the measure of angle D is 4 times the quantity x plus 5 times x, then find the measure of angle C and the measure of angle D. Okay, so what do we say? Supplementary angles do what?
They add up to 80.
Okay, so the angles add up to be 180. Well, if measure of angle C is 12x and the measure of angle D is 4 times the quantity x plus 5, we added them together and we set them equal to what?
180.
180 because they're supplementary. That was the hard part, setting it up. Now, do you remember from algebra what you do first?
You multiply everything up in the
Good. You do the distributive property, which is multiplying. All right, so you do the 4 times the x. Don't forget the 4 times the 5. That's where people mess up. So you bring down your 12x. You've got 4 times x. And you've got plus 4 times 5. What's 4 times 5?
20.
Beautiful. Equals 180. Then you need to combine like terms. Do we have any like terms?
The 12 and the 4.
4x and 12x, which gives you a total of how many x's?
16.
16 x's plus 20 equals 180. All right, now how do you solve for x?
Subtract 20 to 180.
Subtract 20 from both sides. And then you're going to divide. Beautiful. So you get 16x equals 160. You divide by 16 to each side.
10.
And you get x equals 10. That's part of it. That's one part. What else do you have to do?
You have to plug it back in.
Good. You've got to substitute it back in to find out what 12x is, or is angle C. 12 times 10 is 120 what? Degrees. And the measure of angle D. Well, you could do 180 minus 120, couldn't you?
Yeah.
That might be easy.
60 degrees.
It is 60 degrees, or you could do it the old school way, back this way. So you have 4 times 15. It is longer. But again, you could have just done 180 minus the 120. Oh, yeah, 60. Thank you. Degrees.
Wait, is this way more correct or more accurate?
It doesn't matter. Why did I do it? To show you that there's many ways to solve a math problem. There are questions like this in the book. Go back. All right, so example 6, find the measure of angle 3, which is equal to 115, and we know that angle 3 and angle 4 form a linear pair. Well, a linear pair is what? A straight line, and how many degrees is a straight line? 180. Y'all. So we know that the measure of angle 3 plus the measure of angle 4 equals what? 180 degrees. You don't have to put degrees on your work, but that's what it is. All right, so you know this is 115. This one we don't know what it is. I'm going to call it X. And that's 180. Now what do?
You subtract 15 from both sides.
Good. You just subtract 115 from both sides. And you get X equals what?
65.
Yes. Okay, so X equals 65, but the measure of angle 4 is what?
65 degrees.
65 degrees. All right. Did you have to write it out that way? No, you could have done 180 minus 115 if you had seen it. But if you're not sure, write it out. It makes sense. Well, like I know in my head that a linear pair is 180, and I can do 180 minus 115 really quick. But you could have done 180 minus 115, and you're still showing your work. If you knew, but yes, but like, you know, the other one had like 4 times the quantity, X plus 5. You're going to have to do the workout. That is it. Vertical angles. Vertical angles. They're two non-adjacent. Guys, what's non-adjacent mean again?
They don't have the same size of vertex.
Okay. They don't have the same side. They can have the same vertex or vice versa. It can have the same side but not the same vertex. Very good. So one of the things has to be untrue about it, right? They form a form a pair of intersecting lines that are always congruent. So here's the deal. You got 2 lines that intersect. The ones directly opposite of them are called vertical lines, and they're always equal. So if I have line N, they're intersecting. Angle 2 and angle 4 are equal. Angle 1 and angle 3 are equal. If I have something like this, okay? Guys, you see this? 1 and 2 are equal, right? 3 is not equal to 4. Why?
You have the 3 is equal to 4 and 5.
Good. The 3 is equal to the whole big angle of 4 or whatever and 5 are. Okay? No, not necessarily. You can't go unless they tell you. Don't assume that 4 and 5 are equal unless they tell you that it's, you know, bisected or that they are equal with congruent marks. Right. Especially if I drew it, you don't want to go by what it looks like. This one, what do we know about X? So these are vertical angles, and so X has to be what? 100. Okay, it already has the degree symbol, so I don't have to write it. I'm sorry? Could be. Could be. All right, how about this one, 8? What do we know about 75 and X minus 18? Okay, so they're equal, and if angles are equal, you can do what with them? You can set them what to each other? Equal to each other. Thank you for remembering. All right, if angles or things are equal, you set them equal to each other and solve. And he's right, he said he added 18. So X is 93. That's how you do math. You know, you work it out from right to left. Yes, ma'am.
I thought that if they were on opposite sides, they were equal.
They are equal.
X subtracted 18.
So 75 equals X minus 18, but they asked me what X is. All right, so I got to find out what X is. So I added the 18 and solved for X, because 93 minus 18 is going to give me 75. Does that help? Good. Go back. Yes, you always have to show your work. Now, did it have to be written that way? No. You could have done the 75 plus 18. Yes. All right, 8. What do we know?
They have to have the same.
What has to have the same?
2x plus 5 degrees and 3x minus 15 degrees.
Okay. These have to be the same, right? They're vertical angles. What do we know about these two?
They have to both equal 2 degrees.
Mm-mm.
You have to figure out.
Let's figure out what y equals
I'm going to have to figure out what y equals 2, aren't I?
Yeah.
But what is this? Okay, so these are going to form 180 degrees. What do I have to do first, the x's or the y's? Y. Not necessarily because it comes first, but because I can solve for x.
Because it both has the same, like, both.
Good. Good. She's like, because both of these have the variable x. All right? I can't deal with x's and y's in the same problem. Are you listening? I can't deal with x's and y's in the same problem. Why? Does anybody know how to solve for two variables yet? With one equation? With one equation? Okay. So you can't solve for two variables with one equation. Not yet. You have it. Let's pause it. All right. So we have these two problems. They're vertical angles. So what do we do to them? You set them equal to each other. Vertical angles are equal, so set them equal to each other. Now this one you're going to have to write out because why?
Is this the one where you have like a variable side and a...
You're going to have a variable side and numbers on the other.
Yeah.
You've got to solve for your variable. You've got to show your work, right?
Yeah.
Okay, no work, no credit?
Nope.
All right, so you need to get the x's on the same side. I don't care if you move the 3x or the 2x. I like moving the smaller one just because you don't have a negative. All right? If I have 3 x's and I take away 2 x's, how many x's do I have left? Just 1 OX. Bring down the negative 15, the equal sign, and bring down the 5. Now what do you do, Jamar?
Add 15
So you get 20 equals x. All right. So we found the variable of x. But now we need to find what? The y variable. So we've got the x. Now here's the deal. What do we know about these two things?
They add up to 180.
They add up to 180. So I've got the 2x plus 5 plus the 2y, and that equals 180. But remember, we have to have x, which we found, right?
Yes.
What's 2 times 20?
40.
Yeah, we did this last year. Yeah.
Good. All right. What's 40 plus 5?
45 equals 5.
All right. 2y equals 180. Subtract 45 from both sides, and you get 2y. And then you said divide by 2?
Yes.
And, no, it has a decimal, but what is it? 2 goes into 13 how many times? 6?
67.5. 68.
No, 67.5. It has to be exact. Not degrees, it's just 67.5. All right? And then you're done. That's all you, it didn't ask for the angle measurement, it just asked for x and y.
So you multiply that by 2 to get the angle, or is that the...
That's the end of that question, but if it asked me to find that measurement, I would have to take well, it's going to be 135. But I would do 67.5 times 2 to find that angle, but it didn't ask for that. Questions?